So you have a milk bottle. No, just a bottle. And then you have some hard-boiled eggs and a lighter. And, well, you have a lighter. You gotta have something to light, like candles or paper. So for some reason you want to put the egg in a bottle, but you know what? You don't want to squish it because it's hard-boiled and it'll crumble. So you decide to light some paper on fire just for the heck of it, and then you put the egg on top. And then this happens. So why did that happen? So, since you're a scientist and you like experimenting, you decide to put the egg like this, so that there's candles on the top and then the egg is on the bottom. So, it kind of like goes voomp inside. Exactly. So, why is this happening? Now, your science teacher has already told you that there's no such thing as suction, so you've got to think about pressure. And when you think about pressure, you think about the equation PV equals nRT. P being pressure, V being volume, N being moles, or how many atoms you have, R being a constant, and temperature. And so you think of the equation of paper, a hydrocarbon combusting with oxygen.
This equation right here is not balanced. Now we have our balanced equation. So when you're looking at this, you know that when you're getting your molar ratios, you use set coefficients. So the hydrocarbon is a solid, the oxygen is a gas, the carbon dioxide is another gas, and the dihydrogen monoxide is liquid. So pressure in this demonstration was dealing with gases. So we had 4 moles of gas to begin with, however that went down to 2 moles after the reaction of the burning.
But what if paper is not C2H8? Does it work with other hydrocarbons? Well, as a matter of fact, it does. Here, C10H22 shows the same loss of gas. So the egg is literally being pushed in the bottle by the air surrounding it, which has a higher pressure. The burning paper decreases pressure as oxygen in reaction turns into carbon dioxide, resulting in a loss of the gas. The egg would actually shoot up if there was a larger amount of pressure beneath it, but that didn't happen here. But it did happen here. The same loss of gas triggered the movement, and since pressure is constant all around, the air was actually able to push the egg into the bottle, as seen here. Here is how all of this is explained mathematically.
So if you divide both sides by volume and then moles, you're going to get pressure divided by moles is equal to the ideal gas constant times temperature over the volume. In an equation like this, when we have constants, time constant divided by a constant, because they're not changing, we end up with another constant. So let's just say we're going to have that constant as the letter K. So you're starting with a pressure and an amount of moles, and you're ending with a different amount of pressure in moles. So to have an equation to represent this change, we obviously are going to need 2 pressures and 2 moles. And because we have this constant K, it would be, we can say pressure 1 and moles 1 equals K, and pressure 2 and moles 2 equals K. It's a constant. So, using substitution, we derive this equation. Pressure 1 over moles 1, or gas 1, or whatever you want to say, is equal to pressure 2 over moles 2.
Here's an example of this.
Let's say pressure 1 was 1 atmosphere. That sounds good. Just it doesn't matter if you had 2 atmospheres, the relationship's still going to be the same. We had moles 1 equaling 4 moles. We didn't know what our second pressure was, so that's going to be our little question mark, as that's what we'd be trying to find. and then we know that moles 2 was equal to 2 moles. Using our knowledge of algebra, we know that to get x by itself, we're going to multiply each side by 2 moles. So it's going to be 1 over 2 atmosphere is equal to x. So essentially, we have pressure 1 as 1 and pressure 2 as 1/2. So 1 is greater than 1/2. So you'll see as the moles decreased, the pressure also decreased. So in relation, this verifies our egg demonstration, as the burning of the hydrocarbon inside the bottle decreased the pressure as the moles were decreased, causing the atmosphere on the outside to force that egg into the bottle.
Like this. Or like this. So now you know why this works and what pressure has to do with it.